Now let's see what are all the problems we might get while executing transactions in a concurrent manner. So by classifying all the problems into various classes, we can see that whatever method you come up with is going to solve all these problems. Okay. So the first problem is lost update problem or write conflict. In operating system also you might have seen something called as race condition. In a race condition, let us say if a value of variable is 5 and if there are two processes P1 and P2, if process A is going to increment it and process A is going to decrement it, and if you are going to see these operations in the interleaved fashion, there also it is going to do something like this. One is it is going to read the value of A and then increment the value of A, right, and then write the value of A. Now let us say here there is a preemption because of which it is going to read the value of A, which means before writing the value of A it is going to read the value of A, right. See here the value of A will be 5 and when I increment it is going to be 6, but it has not yet written the value back, right. Now what will this one see? It will also see the same value 5. Actually it is supposed to see 6, but then it will see 5 only because update is not done there, right. Now if it tries to write here, let us say it is decrementing A, right, and if it is going to write A, then what happens is if this one performs the write, then A will be written as 6, and then after this decrement is done on the local copy, which means on this 5, so this one will be decremented and here the value of A will be 4, and now if the write is done 6 will be replaced with 4. Got it? So if I increment it and decrement it, actually the value should remain same, but then because of this problem, right, we are going to get inconsistent value. So this problem in operating system we called it as race condition. Now the same way we can look at the problem here. It is given a different name. It is called as lost update problem. So lost update problem is whatever you did, see here also, whatever updation you did here, that is lost. One of the updation is completely lost. The updation of incrementation is completely lost. Now what is reflecting there is only decrement, right? Therefore one of the updates is lost. Here also the same thing will happen. Look at this. Now there are two transactions. Now one transaction is trying to decrement the value of A by 50, which means is actually transferring money from A to B by 50, and the other transaction is trying to increment the value of A by 4%. Now let us say while executing this transaction there is some preemption here, right. Now at this point if the second transaction has started, now see this, the local copy of A will contain 50 and at this point the value of A is going to be, let us say initial value of A is 100. Let us say initial value of A is 100. Now the local copy of A at this point is going to be 50, but then it is not yet written. Therefore this update will be in the local temporary, let us say, memory. It is not yet propagated to the hard disk. Now when you are reading the data, you will again read from the hard disk. Now this one is going to see that the value of A is 100 here, and whenever you have incremented the value of A by 4%, right, then it is going to be 104 at this point, right, 104 only, right. Yeah, 4% is 0.04, right. Okay, so it is going to be 104, and now based on who is going to see, the local copy in this transaction is containing 104 and the local copy in this transaction is containing 50. Now based on who is going to write it at the end, the value of A will depend on that, right. For example, if this one is going to write the value, now let us say what has happened here is this one is writing the value first and then this one is writing the value. Now even though it is going to make the actual copy in the hard disk as 50, later this one is going to overwrite on that and it is going to replace this 50 with 104, Got it? Therefore, the final answer is going to be 104. Actually, if it would have been done one after the other, then what should happen? There should be a change in 50, and then you have to increment it by 4%, or after this you have to increment by 4%. The actual answers would have been different, right? But then because of this change, one of the updation, which means actually this updation is completely lost. So the overall effect is as if this has never happened, isn't it? Even though this happened, even if this has never happened, you are going to see the same value, which means this updation is completely lost. That is why the problem is called as lost updation problem. So you have to write the concurrency control mechanism in such a way that this problem will never arise, right? Okay, let's see other problem. So this is also called as write-write conflict. Okay, one more name is write-write conflict. Why? Because of these two, right? Now when will this occur? Whenever you are going to have two writes without any read in the middle, then this is going to occur. Got it? When you have two writes on the same data item, this is also important. When you have two writes on the same data item without having any read operation in the middle of the data item, then it is going to lead us to write-write conflict. See, now this one and this one is not going to give us any conflict, because even though it is write-write, here it is about B and it is about A. So two writes have to be on the same data item. Got it? Okay, let's look at the other problem. Now this is called as dirty read problem. So what is dirty read problem is, let us say a transaction has executed for some time and then it rolled back. Before rolling back, if some other transaction has read the data which it is not supposed to read, then it is going to be dirty read, which means you are actually reading some data which is not committed. I'll just take the example and show you. See this? Now assume that transaction T1 has started the same way and it is trying to transfer money from A to B, and so it has decremented the value of A, and after decrementing the value of A, it has written the value of A, which means the final copy or the actual copy of A has been modified. See, here A has been modified locally and the change has been transferred to A, right? So which means initially if A was 100, this is decremented by 50, and so A is made 50, and now this change has been transmitted to the hard disk, from which let's say T2 has started reading, and so T2 is now seeing the value of A is 50 and it has done its computations. So let us say here also 4% is what is going to be increased, and now if I try to increase it by 4%, it is going to be okay, so it is going to be, I think, 52 rupees, right? So now if you observe it, at this point it is going to be 52 and now it is going to write there. So again here it is going to be written as 52. Now let us say at this point, so after this transaction is over, at this point again T1 has started executing. Now let us say T2 has somehow failed here because of the hard disk failure or hardware failure or some other failure, power failure, whatever the reason is. Now it suddenly stopped executing, and later what will our concurrency control system will do is, or the recovery manager will do is, it will try to roll back the entire transaction, because if it is not completely done, we have to start it again. Now when it rolls back, right, which means it is going to undo all the operations it did. Now what will it do? It will try to see that, okay, I have changed the value of A, therefore let me restore it to the original value. Here the original value was 100, now it will try to restore it back to 100. Got it? Now because of this rollback, again this updation is also lost, isn't it? Which means we are going to get wrong values whenever you are going to read a value from a transaction without that transaction getting completed, without that transaction getting committed. So committed means whatever modifications you did, you are not going to undo. If you have not committed the transaction, which means at the end there is something called as commit, right? So if you don't see this commit, it means that there is still a chance that whatever modifications we did to the data items here, we'll just undo them, right? So you have to wait until a transaction commit, then only you are supposed to read the data by it. If you do it in the middle, there is a chance that we might be reading some dirty values, right? So in this case, dirty values means a value which might change later. Got it? So how to solve this problem is just wait for the transaction to complete, then only you are supposed to read it. Otherwise, whenever this transaction is going to roll back, again this transaction also should roll back, and both of them have to start simultaneously. Okay, how to solve it we shall see later. This is what the problem is. The problem is, if you are going to read a value from uncommitted data, then you are going to face some problem, right? You have to read the values only from committed transactions. Got it? Okay.